All right, hello. Welcome to Chapter 5, Trig Identities. Now, before we get into the identities, we're going to be using a lot of our algebra skills back from Algebra 2. So we wanted to take a day to review and refresh our memories on how to factor. And then we're also going to look at some rational expressions later. But today, our main focus is on factoring. So I have a little cheat sheet summary of some of the main types of factoring. And I want to just look at the method, like the pattern, and then a quick example. We're going to do a couple together and get to our homework, okay? So one of the most common ways I don't have on here, the first thing you should look for is a GCF, right? Always look for a greatest common factor to factor out first. That's always the first thing you look at. Then after, if you have two terms left over, if those two terms are perfect squares and you're taking the difference of them, then you can take the square root of both of them. So like the square root of a squared is a, square root of b squared is b, and you have a plus b, a minus b. You always have one sum and one difference. So if that's the pattern for the difference of two squares, you may have your teacher may have referred to this as dots, difference of two squares. You might see it in a little bit more an advanced way where the terms that are perfect squares aren't just basic like 9x squared, right? Like this one, the square term is 3x squared is being squared. So 3x squared is 9x to the fourth. What squared would get you 25y squared? Well, that would be 5y. So notice your a and your b values are 3x squared and 5y. So we have a 3x squared plus 5y, 3x squared minus 5y. So that's how we would factor this difference of two squares, okay? What if we take out a GCF, or there's no GCF, and then there's three terms left over? Well, that would be factoring a trinomial. There's lots of different trinomials that we have. If the leading coefficient is a, what we do is we do a times c, and we ask ourselves, what multiplies to equal a times c, and what adds to equal b? Okay? Whatever that is, that we're going to take those two numbers, and we're going to split the middle term with whatever those are. So we're going to have ax squared plus whatever the two numbers are with the b plus c. And then we're going to factor by grouping. Okay, so that's the general pattern. I know that's a little bit abstract, so we don't have any numbers. So let's take a look at a quick example here. To the right. So let's say we have to factor this 3x squared plus 13x minus 10. So I'm just gonna, since that answer gives it away, it takes away all the element of surprise, I'm just gonna wipe this out. And instead, I'm gonna write out my steps. So there's no greatest common factor that I can take out. So I'm gonna think of what multiplies to negative 30 and adds to 13. So what two numbers multiply to negative 30 add to negative 13. So right off the bat, some of you might be thinking 10 and 3, but they wouldn't add. One of them would have to be negative in order to multiply to be negative, and they wouldn't add to that. So instead, it's actually 15 and negative 2. So don't be really careful. Try not to make any mistakes, silly mistakes like that. So we take the 15 and the negative 2, and we're going to split this middle term. In other words, 13x is the same as 15x minus 2x, right? Doesn't 15x minus 2x equal 13x? So we're just splitting the middle term up into two separate terms and then rewriting the first term and the last term as normal. From here, we're going to factor by grouping. So we're going to group the first two terms together and the second two terms together, and we're going to factor out a GCF. So from here, the GCF of 3x squared and 15x is 3x. The second one, the GCF is negative 2. And what we do is inside we write out what's left over. So 3x squared divided by 3x leaves us with x. 15x divided by 3x leaves us with 5. When we divide both of these two terms by negative 2, negative 2x divided by negative 2 is just x. Negative 10 divided by negative 2 is positive 5. You will notice that we get these two groups, these two factors that are the same. We want that. If you don't get a common group here, you did something wrong, because that common group that's repeated is one of your final answers. And the GCFs combine to make your other factor, 3x minus 2. And so we can follow this method each and every time we need to factor a trinomial. Okay? There is one unique type of trinomial that it's probably been a while since you've seen it, and that's called a perfect square trinomial. So I just want to remind you about that. A perfect square trinomial is in this form. It's still a trinomial, so 3 terms, but what's unique about it is the first term and the last term are both perfect squares, and the middle term is 2 times the square root of this one and the square root of the last one. Okay, if your trinomial is in this form, and the giveaway is that the first and the last terms are perfect squares, then we can factor it into ax plus b times itself. In other words, it's a perfect square trinomial, I said, right? So another way you can write it, think of it as ax plus b, that quantity squared. Okay, now if the original trinomial had a negative, if it was ax squared minus the 2abx and so on, then it would just be minus in your factors, and it would be ax minus b squared. So let me show you an example of that here. So if you have 4x squared plus 12x plus 9, notice 4x squared and 9 are perfect squares. So your a would be 2x and your b is 3. So if we plug that in, that would be 2x plus 3 times itself, 2x plus 3. Now always double check to make sure. Notice that a and b, 2x times 3 times 2 should equal your middle term, right? 2 times ax times b is your middle term. So 2 times 2x is 4x. Times 3 gets us 12x. So we know that this will actually FOIL back out to be your original trinomial. This is a nice little pattern if you're familiar with it. However, if this confuses you and you're not sure how to work with it, don't worry. You can always use the split the middle and factor by grouping method that we talked about up here. This is just a more unique trinomial that you might see and a faster way to factor it. Okay, and the last one, so we talked about quadratics. What if we have cubic functions, okay, cubic polynomials, where we have a cubed plus b cubed, or a cubed minus b cubed? Well, they both follow the same pattern. The pattern we're going to use here, do you guys remember from last year, is SOPs. I'll do it in orange so we can coordinate here. SOPs. So this is what you say to yourself when you see the sum or difference of two perfect cube numbers. So first you have to think of what are the base numbers for what are a and b, right? So you put a, so if it's a cubed plus b cubed, the first sign is the same as the original polynomial. So the s in SOP, it means the same sign, and it's just a plus b. Now the other signs for this following trinomial are going to be the opposite of what you started with, and then the last sign is always positive. So this is always positive no matter what. Notice the sign if it's a cubed minus b, it's same, opposite, positive, right? So the SOP, that purple SOPs, refers to the signs in your factors, okay? The SOPs, S-O-P-S, refers to what these terms actually are. So in your trinomial, this first term is the square of a, so a squared. The second term is the product of a and b, and the last term is the square of b. So knowing that pattern, we can apply it here. So here are two examples. The first polynomial that we're factoring is ax cubed plus 1. Notice 8x cubed, that's 2x being cubed, because 2 cubed is 8, x cubed is x. So our a value, our first term, is that 2x. 1 is also a perfect cube, it's 1 cubed. So notice we have the 1. So if we follow the SOPs, the original polynomial we're adding. So the first sign is the same, then it's opposite, and then the last sign is always positive. Then we get the actual values for the polynomial. Notice the first value for the polynomial is 2x squared. 2x times 2x is 4x squared. The middle term is the product of these two. 2x times 1 is 2x. And the last term is the square of this one. And so 8x cubed plus 1 factors into this binomial times this trinomial. And to remember how we get it, you come up with your base numbers, a and b. The first one is the same, a plus b. And then you follow SAPs for the rest. So for this one, 27, a to the 6th, minus 125 y cubed. This is way more involved, bigger numbers, bigger exponents, but follows the same pattern. 3 cubed is 27. A squared cubed is a to the 6th. You guys remember we multiply exponents? In the same way, 5 cubed is 125, and then y cubed is y cubed. So we get our base values, 3a squared and 5y. Notice 3a squared and 5y. So we do the SAPs. The first original sign was minus. So it's the same sign in the binomial. Then we have the opposite sign, and the last sign is always positive. So same, opposite, positive. The SAP, same, opposite, positive. Then to get the 3 values in our trinomial, it's this first term squared. So 3a squared is 9a to the 4th. This middle term is the product of these two. So that's where you get the 15a squared times y. And then this last term is the second term squared. You get the 25y squared. And this is our trinomial. Now these are our factors of this difference of 2 cubes. Now this trinomial will not be able to be factored. This trinomial that you get after SAPs will not be able to be factored. Okay, so these are ways of factoring that you should have learned last year. This was a very quick review. If you need to, rewind, listen to it again, but we're gonna have lots of practice problems. So let's just really quickly look at this algebra factoring. So if you see a trinomial like this brings us back to first looking for a GCF. So we take out our GCF as 3. We'd be left with 2x squared plus 9x minus 5. Inside, we would see this trinomial where we could ask ourselves what multiplies to negative 10, adds to positive 9. That's going to be 10 and negative 1. So we're going to split the middle term into plus 10x minus 1x. We rewrite the first and last terms, and then we factor by grouping. So we'll group the first 2 terms together and the last 2 terms together. Once you group them, you take out the GCF. So the GCF of that first group is 2x. The GCF of the second group is negative 1. We always want our x term to be positive. So we'll take out that negative 1 here and then write the remaining factors. So this will be x plus 5. When you factor out negative 1, we get x plus 5. Notice that common factor. That's one of our factors. The other factor is the combined GCFs. So 2x minus 1 becomes the other factor. And then don't forget about your GCF way from the beginning. So here is the factored form of this polynomial. So we took out a GCF, and then we used split the middle and factor by grouping. Okay, so that was really quick explanation for how to factor this polynomial. But remember, this is our trig semester, right? This whole semester is for trig. So why are we reviewing how to factor all these polynomials with trig? Well, what you're going to see is that you're going to have polynomials now with trig functions in it. And oops, this is my bad. Go ahead and add this. This should say sine of x, not just regular x. That should be sine of x. So when you see a polynomial with sine squared and sine of x in it, think of your algebra. So what you can do is think to yourself, well, this looks like the form x squared plus 10x plus 16. The way we factor a polynomial, a trinomial like this, is what multiplies to 16 and adds to 10. Well, that's 8 and 2, right? So we would factor in this easier form, and this basic would be x plus 8, x plus 2, right? That's if this was an easier, just basic algebra trinomial, but it's not. The x squared is sine of x. The sine squared of x. The x is sine of x. So wherever we see x, these should actually be sine of x, right? So we have this little change. We kind of think with our basic strategies, but then we have to put the trig functions in. So we would factor the sine squared of x plus 10 sine of x plus 16 into sine of x plus 8 times sine of x plus 2. Now, if you get confused, remember, all we're doing is rewriting the polynomial. This expression and this expression should be equal. That means if you were to FOIL this, you should get back to this original polynomial. So let's try it out. Sine of x times sine of x is sine squared of x. So far, so good. Sine of x times 2 is 2 sine of x. And then 8 sine of x. 8 times 2 is 16. Do you guys see that 2 sine of x plus 8 sine of x is 10 sines of x? So we have sine squared plus 10x plus 16. Look at this, you guys. This polynomial, when we FOILed out our factors, is the exact same as what we started with. So we know our factors are correct. So you can always go and FOIL your answers and see if you get back to your original function, but you do not have to do this, right? This is a way that you can check, okay? You can check by FOILing and see that if you FOIL your factors, your answer is the same as what you started with, okay? But remember, your strategies, your approach are all the same. Your variables are just a little bit more complicated. We threw in the sines of x, the trig functions in there, okay? So go with me to your worksheet packet. If you need to pause to pass it out, go ahead and do that. But I want to do just a couple questions together with you. And actually, I'm going to do that on a separate video. So you can stop this video and play the next one for explanations for a couple problems on worksheet 1.